Hello, hello, hello. Hi, Jackson. Can you hear me?
Yes.
Okay, great. So we'll give people a chance to join, but get out assignment number 4. We're
All right.
gonna we're gonna work on it today and finish it.
Perfect.
We'll give people a couple of minutes. Okay, so we're gonna start today. We're gonna work on. Let me. So what I'm gonna ask you guys to do is to open up your assignment, assignment number 4, and I'm gonna go through the solution. Make sure that you guys get it right. So I'm assuming that what you did was exactly what I had mentioned that you do. So you split this up into 3 different shapes, right? Now just remember in this case, this shape here, this one, it's actually a void. So make sure you understand that this is going to be negative. That's shape number 2. So this is going to be shape number 2. And then what you've got is you're going to split up the other areas into 2 separate shapes. So this is going to be area number 1. That's this one over here. And this is going to be area number 3. Okay. Now what you do is you set up your table. What does your table look like? Well, let's take a look. So your table is going to look like something like this. First, you're going to put down the area for each shape. Remember, this is going to be number 1. How do you determine this area? Well, you know based on this. Let's see. We have here that 6. So this is 6. So this, hold on, let me use this. So this is 6. This is 6 inches, and this is 4 inches. So the area is going to be 6 times 4. And there you go, 24 square inches. Now, for the second area, it's going to be 1 times 2. So it's going to be 2 square inches now, but it's a void. So you're going to put a minus in front of it, right? That's key. That's important. Now, the third is, remember, it's half base times height. So if this is 4 inches to this distance, and this distance, what is it going to be? Let's see if I can find it. So we have to determine what is this distance here. Mm, let's go back to the question and see if I can find it. There you go. The question gives it. This is going to be 7. It's going to be 7 minus 4. So this distance here is going to be 3 from here to here. So half base times height, what is that going to be? So the height is 6 inches. So half base times height, right? So half base times height is going to be equal to 0.5 times. So the base is going to be 7 minus 4, 3 times the height. Oops, that should be 0 point times the height. That's 6. So what is that equal to? It's equal to 9 inches square. And there you go. You've got that right here. Now, because that is an actual part of the shape, so that's not going to be a negative. That's going to be a positive. Now, here's where it gets interesting. Here's where it gets interesting. Let me erase that. What you need to do now is determine the x component, or x for this. And remember, we're using this corner here as the origin or the reference. And if you look at the shapes, what you need to do in the shapes is you already know from each typical shape where the centroid is for x, and you know what x bar and y bar is going to be. So you're going to use that. So in this case, we're taking a look at the x for the shape number 1. It's 4 in this direction, so it's half of 4. It's going to be 2. And there you go, 2. And then what you do is you calculate x times the area. That's 48. Then you look for y. So for this shape, y is going to be halfway up. It's going to be 3. So you plug that in, it's 3. And so y times the area is 72. Now let's come back to this shape here. So you know that the centroid is somewhere in here for this shape. Somewhere in this shape. And then this area here. So you are going to use the information that you have to determine what this distance is. So again, let's go back up to see where the x is going to be. The information given. So this is 1 inch wide. It's 2 inches from here. And you know that the centroid for this shape is going to be here. So it's going to be 2 inches plus half an inch.
Sorry, sir?
Yeah, go ahead.
Are we doing assignment 4 or 5? Because the numbers are different for the
Right, right,
assignment 4.
right. So this is assignment 4, but ignore this, ignore this, because this is for a different year.
Okay, because like with the because it had different numbers. You had like 2.8 while we had like 2. So I got confused by that.
Okay, all right. So let's see. What do we have here? Just let me see. Well, let me see what I've posted for you guys. So assignment number 4 is exactly what I'm working on. So isn't this assignment number 4?
Yeah, but like because earlier there was like a different one. That's what I was confused about. There's like you had numbers like 2.8 and all that jazz. Like I swear to God, it was different. Maybe it was
Okay,
just
where do you have 2.8? Where do you see 2.8?
no, it just where it said like two, it had 2.8. I swear to God, there's a different one. I might be going insane. I'm sorry.
Okay, because I don't see 2.8 anywhere.
Oh, right there. The solutions are
Right.
confusing me.
Right. So that's a part of the solution. So we're getting there. We're
Oh,
getting
okay.
there.
The solutions are confusing me. I'm
Yeah, because
sorry.
this is X bar. This is what you're going to end up with at the end. Okay. So what you want to do is um, you're going to use the X. So you're going to look at the centroid here, right? The centroid is here. You know that, right? How do you know that? From the shape. It's going to be halfway to here. So it's 2 inches. So this is going to be 2 inches, right? Because of what you've got here. This is 2 inches. Why? We know it's from here. And then this is going to be another ½ inch because this is 1 inch wide. So that's another ½ inch. So what you have here is for that shape, the X is going to be 2.5. Does that make sense to everybody, or do I have to go through? Should I go through that again?
I understand it now. Thank you.
Okay, good, good. Now, where do you plug in that 2.5? Well, let's go ahead and take a look. Where do you plug that in? That's where you plug in 2.5 for that shape. And then you do the same in terms of the Y for that shape in the calculation. So you know that the Y of the centroid is here, and it's halfway up, right? So it's going to be this 2 plus 1. So it will be equal to, so the Y will be equal to, for this shape, 3, right? So the X is going to be, X is equal to 2.5, and the Y is equal to 3. That's for this shape here. And you plug that in to your table. You go 3. Now you can determine X times the area, 2.5 times 2, but it's a negative, so it'll be -5. And then you've got Y times the area. So that's going to be 3 times 2 minus 6 inches cubed. Then what you do is you do the same for the last shape, right? You know, based on the shape of a triangle, that the centroid is going to be, let's see if I can draw it, the centroid of it is going to be somewhere here, 1/3 based on the shape. So it's going to be 4 plus 1, 5. So 4 to here. We know this is 4 because of this. And we know based on the shape that it's 1/3. So that's going to be 1. That's 4. So X is going to be 5 for this. And Y, again, I'm going to do 1/3. So it's going to be 2 because it's 1/3 of 6. Let's see if I'm right. I think it's going to be 1/3. It's equal to 2 because it's 1/3. Let me erase that and go back. Otherwise it comes in the way. And we know the area is what? 1/3 base times height. We've already plugged that in. So it's 5 and 2, like I said. Why is it 5? Because it's 4 inches this way plus 1 inch. Why is it 1 inch this way? It's 1/3 of the base. And then the centroid for y is 1/3 of the height. So in that case, it's 2. And then you plug that in. You know the area, you know x, 9 times 5, 45. You know the area, you know y, it's 18. So what I'd like you to do now is to go ahead and calculate, add all of these, add all of these. So what you want to do is add all the delta a's, add all the x times delta a, add all the y times delta a, and plug these into these formulas, right? You know what the total area is. How do you know that? 31. It's 31, 31. You add all of the x times delta a, that'll give you 88. And you add all the y times delta a, that'll give you 84. So go ahead and finish that off. I'll give you guys about 5 minutes to do that. Okay? Or maybe 10 minutes, and then we'll work on the next one.
I'm sorry, but can you just go over how you found X one more time
Which
if you
one?
don't?
Which one?
Let's just say X for the component the 4 times by 6.
4 times 6, right? So you know that the centroid of such a shape, so this is the shape, right? The centroid is halfway along the x-axis and halfway along the y-axis. So the x-axis is 4. It's 4 inches along the x-axis. So x is going to be 2. Remember, halfway along the x-axis, halfway along the y-axis. Why? It's a rectangle. So the x is going to be 4 over 2, 2. Y is going to be 6 over 2, 3. So x is 2, y is 3. Does that make sense, Kayla?
Yes, and then can you just go over the triangle one then? How you got the
Okay.
X for like the 3 inches?
So here's what happened. Let me try to help you there. So we know that for this shape, this is 4, right? We know that's 4, correct? 4 inches up to here. Do you agree that that's 4 inches?
Yes.
How do I know that? Because of this. And you know that the centroid for a triangle is 1/3 of the base in this direction.
Mm.
The centroid is somewhere here. So it's going to be 4 plus 1/3 of 3. Why is it 1/3 of 3? This is 3. So the answer will be, so this is 4, this is 1, it should be 5. Is it 5? Right here. Okay, because what you're doing is you're adding it from this reference point. And in terms of the y, well, you don't need to add from any other shape. You can just look at 1/3 from the height. So the height is 6. What is 1/3 of 6? 6 divided by 3 is equal to what?
2.
What do you have here?
Yes. Okay. Okay.
All right, so this is being recorded and it will be posted, if not today, tomorrow. So it should help you. Anybody else have questions? If not, just go ahead and solve this. I'm going to erase everything to not confuse you. Because it's one thing to get this table correct, then you want to use the information in the table correctly. So it's going to be x bar. What is x bar? It's the x coordinate for the centroid of the shape. Another thing I want to mention is, why is this negative here? This is negative here because let me erase that, sorry. It's negative because it's a void in this question. It's a void. And how can you tell if it's a void? It should be indicated. And if it's not, I'll indicate it in the question for you. Go ahead and finish that calculation. And then we'll work on the next one so you guys can submit this today on time. I'll give you guys a few minutes more, a minute or two more.
Yeah.
Hello, Karen. What's going on?
Hello.
Hey, what's going on?
Nothing much.
Are you guys ready to work on the next one?
So the answers would be X would be 2.8 and Y would be 2.7 inch.
Yes, correct.
Okay, because we don't have the square thing because they minus from each other. Okie dokies.
Okay. So now what we'll do is we'll take a look at the next question, right? And there's two ways that you can complete this. And so this is where you can, first of all, you split it up into three shapes, just like the you did before. So that's shape number one, shape number two, shape number three. And shape number one would be this one right here. Shape number two would be this one right here. And shape number three is this one right here. So let me just erase that. And what you're trying to do is, instead of having your origin on the side somewhere here in this solution or this type of solution, what you can do here is put in a y-axis right between the structure and an x right between the structure, in the middle of the structure. And so what you would do is you would be calculating the ix component, so the moment of inertia around the x-axis, or you would be calculating the moment of inertia around the y-axis. So ix and iy. So let's go ahead and work on this. So first, let me point out that you have the y-axis right in the middle, and we'll do that second. First, what you want to do is you want to have the x-axis right in the middle, right there, right? So that's the first one that we'll do. Now, the areas of each are, so for this number one, it's 6 times 2. Remember, this is 2, this is 6. 6 times 2 is 12. That's where you get that 12 right here. The area for the second shape is, what is the width? Let's see. Go back to the question. What is the width? The width is 2. So this is 2. And the length or height is 6. So that means it's 6 times 2. That's 12. That would be the area of shape number 2. Then shape number 3 is going to be 12. It's 12 times 2, 24. Okay. Now what you're going to do is you're going to determine the y component of the centroid. Why? Because the x component is going to be 0. And this is another way of performing this calculation. So for shape number 1, what's the y component going to be? So we know the centroid for shape number 1 is up here. It's halfway up, so that's going to be 1 from here. Now what we want to do is we want to determine what it is from here. So this is 6 inches. What is the y component going to be? So let me think about this because I think I'm confused here as well. This is the centroid. This is the reference. Right here is the reference. That's 1 inch right here. So let's go ahead and, so that's 1 inch right here. That's another 6 inches right here. That's 6. That's 1. That's another 1 inch. Here, so shouldn't that be 8? So that's a reference. 2 inches, that's 1. Plus 6, that's 7. 7 plus 1. But it's actually, the solution is 9. Unless the origin reference is here. So what I did is I did this wrong. So let me erase that. I think I know what I did wrong here. Now this remains 6. This is 1. This is 6. So the reference is actually here, according to the solution. I was thinking I'm going to do the reference here. So this will be 2. This is 1 plus 6 plus 2. That's why that's 9. Does that make sense to you guys? Remember, for this, the centroid for the first shape is, so let me delete all of that. So what we want to do is, in this solution, is use this as a reference right here. And we know that the centroid for this shape is going to be here. And the x is going to be 0. Why? Because we're going through the center of it. So the only thing we're dealing with is the y component of the centroid. And so this is 2 inches. This is 6 inches. This is 1 inch. So that's why we end up with 9 here. Are you guys all clear on that? And don't worry if we don't finish this in today's class, we'll finish it in the regular class. We want to make sure that you guys all get it. We'll extend the due date a few days. Now, 12 times 9, 108, right? So we now want to determine Ix, the moment of inertia, or the moment of inertia Ixc. And what's the formula? BH3 over 12. What is B in this case? 6. Height is 2. So 6 times 2 times 2 times 2 divided by 12. What does that give us? Let's go ahead and try that. I'm assuming you can see my calculator. So BH3, so that's going to be 2, 2, times 2 times 2 times 6 divided by 12. Is equal to 4. So that's where we get this. That's the formula, BH3 divided by. So right now what we're calculating is the moment of inertia, the x component. So that's why we use this formula for this next part, BH cubed over 12. What's dy going to be? What's dy going to be? It's from the reference. Dy is going to be 5. dy1. And dy2 is going to be 1. It's from the x-axis, or the x-axis. Dy is going to be 5 from it. Going to be 1 plus 4. dy2 is going to be 1. And dy3 is going to be 3. So when you plug these numbers in, 5, 1, and 3, and then you can calculate a times dy squared. It's going to be 300. A times dy. It's going to be 12. So it's 12 times 1. And 24 times 3. Hold on. How do you calculate this? A area times dy squared is 216. So when you sum that, that's going to give you 528. And then when you sum y times the area, gives you 192. And then you sum the area, which is straightforward, gives you 48. Now, where do we get all of this? Where do we get all of this? You have to go back to the notes, the parallel axis theorem. And how you use the information given to calculate that. So we'll have to go through that in class. And like I said, I'm going to have to extend your time to submit this because we need to go over this again. I didn't realize that we hadn't touched on it at this level before. We need to go through some more questions before you can submit that. So while I have you guys here, I'm going to make a change to the due date for assignment 4. We'll push it to Thursday of this week. Okay. That way you have a few more days to finish it. Because I think we need to go through the theoretical part more. Because you guys are not responding. And I don't remember if I had gone over the basics. I might have asked you to check the notes, but I'm not sure if I've gone over the basics Okay, so what we'll do is we'll work on this question in class and similar questions on Wednesday. Is it Wednesday that we have our in-person class?
Yes, at 10:30.
Yeah, so the due date is going to be extended because I don't think that we've done any examples of these before, have we? Because so what we're looking at here, so in the first question, we got the centroid of the shape, composite shape. Here, we're trying to get the moment of inertia around the x-axis and along the y-axis. So it follows a lot of the same principles, but I feel like we have to discuss this a lot more. We don't have enough time to finish it today. Do you agree?
I agree.
We need to go over this a few more times. We've only got 10 minutes left for today. Okay, so we're going to stop there. I'm going to let you guys finish up the first one. And I'd like to ask you guys, and I'll probably do the same, to take a look at some of the posted items from moment of inertia, and that's what we're going to work on Wednesday. And then that will be the end of week 12. Week 13, we will work on a radius of gyration and a review for your final. And I think we'll work on an assignment as well. We'll finish an assignment in week 13. Although we might run out of time. So what I might do is I might just add the marks from the assignment 5 to the previous assignments. That would make it easier so that you can just focus on preparing for the final test. But so there's two concepts that we need to work on or practice: radius of gyration and moment of inertia. And if we don't have time to practice radius of gyration, we'll just look at it theoretically, but it might not be in the test. It might just be that you understand the theoretical calculations. We'll see, or it'll be a very basic calculation, because right now we still have to practice moments of inertia. I think you should be okay for the centroid of a composite, but a moment of inertia, I think we need a little more work. Okay, so finish up the first question and take a look at how to calculate moments of inertia. And then we will meet on Wednesday morning. And I'm going to stop the recording now.